Welcome back to Master Tech, and in today's video I'm going to show you how I rebuilt the classic trivia game Jeopardy from scratch in Python. Now, Jeopardy is an extremely famous trivia game, so being a programmer, it was kind of like a fun project I've been working on for a long time to rebuild the classic game from scratch in Python. Today I'm going to do sort of equal parts project showcase and code walkthrough, and of course the whole project is linked in a GitHub at the description below this video. And because this project was developed when I had little chunks of time over the last several months, I'm not going to do a line-by-line code along tutorial. It's a little bit easier to just show off the project and what it does, and then explain to you what the code is doing overall. So if you grab it from GitHub, decide to play the game, or add features yourself, you have a decent starting point and understanding. So I basically started from the concept of I wanted a PyGame game Python project to be as close to the main concept of the popular Jeopardy trivia game as it could be. And that is a 3-contestant game with essentially a 4th person that needs to be involved as kind of the game master. So in the United States, the person who hosts the show most famously is Alex Trebek, rest in peace. But basically, he would read off the questions. He would tell players if they got the answers right or wrong. He would have access to the answers. And then the 3 players would just sort of raise their hand, buzz their buzzer when it's time to answer the questions. So to replicate that functionality, I built a 3-player mechanism where you can set the names of the players within your game. And then the 4th player, the game master, will have access to the answers from the game in the console window of the Python window. So the way Jeopardy is played is you start with a player, typically whoever won the previous game in Jeopardy, but you can just pick one. So I'll say it would be, Dale. Dale would pick name the classic song for 200. So the game master would click on that button. I wish that I had his girl. Where can I find a woman like that? The game master would read that. And that's a classic rock song, Jesse's Girl. So if Philip raised his hand or buzzed a buzzer first, then this timer would start counting down. He'd have a chance to say Jesse, and if he gets it right, then he gets 200 points. Then Philip is in control of the board. And if Philip said, name the classic song for 800, question pops up. The game master says, help me, this woman whose name repeats 13 times in the chorus, help me get her out of my heart. Let's say Fleo tries to answer it, but he doesn't know that it's Rhonda. Well, then the game master has to say, no, that's wrong. And then Fleo would lose that many points. Dale could then try to answer it and say, it's Rhonda. And then he's in charge. Hey, laddie, for 200. Flying may not be all plain sailing, but the fun of it is worth the price, said this woman who would know. It's Amelia Earhart. Let's say nobody answers it in time. The question just times out. No one loses points, and Dale gets to keep going. So if you haven't seen Jeopardy before, I'm surprised you found this YouTube video in the first place, but look it up. It's an incredible game. I'm not taking credit for inventing this style of trivia game. But the cool part is in Python, I built a program where as your mouse is hovering over the various questions you can click on, it'll change colors. And then interestingly, you can see I didn't iron out all of the formatting, but you've got your categories up top. You've got the dollar signs on every question. So it really is a pretty darn accurate recreation of Jeopardy. And then we're going to get more into each of these buttons later, but there's a menu, there's exit buttons, there's restarting, there's rules and instructions. You can edit your players' scores if you did something wrong, and the names as well. So that's all pretty cool. It's a pretty fleshed out game for a little like hobby project that I built in my spare time. But now I'm going to just sort of pause the tutorial real quick so that I can finish single Jeopardy so you guys can see it cut over to double Jeopardy. Okay, so I've got one question left in single Jeopardy, food for thought for 1,000. Monosaturated fats, unsaturated fats, and these alligator pears can lower blood pressure and promote a healthy brain. I would not be a great game master. But so when the last question of Single Jeopardy is answered, it goes to Double Jeopardy. And you can see we have all the new categories, we have all the new dollar amounts, and in Double Jeopardy, the gameplay mechanic is exactly the same as Single Jeopardy. It's just now all the prices are doubled. So also to give you guys an idea of while you're playing this, how the game master should have it, well, the way I built it is the answers to each question are getting printed in a Python console. So whatever IDE you're running this file from, or even if it's from the command line, you just want two monitors, two screens basically, and you can have this up on one screen, and then you want the Python console running on a second monitor off to the side. So like I have two monitors. The host, the game master, would put this on like his laptop screen and then maybe throw this up on a TV screen acting as a monitor or something. That was my basic intention when I built this. I'm sure there's other clever ways of doing it. But that's sort of how you're supposed to play the way I built it. Okay, and since the gameplay for Jeopardy, Double Jeopardy is so similar to Single Jeopardy, I'm just going to take another quick pause here, finish out the level so that I can show you guys Final Jeopardy. Alright, so we're on Men of Michigan for 400. We're going to finish out Double Jeopardy. Looks like Eminem. Okay, so you can see Final Jeopardy. The category is the 1500s. The question is in the early 1500s. He produced a codex in words and pictures of the flight of birds. And the thing about Double Jeopardy, if you're not intimately, or Final Jeopardy, if you're not intimately familiar with the game Jeopardy, is it's a very manual process. So when you're building a program to do this, there's not really a great way unless you were also building like an app portion that was going to be on the players' phones, which is out of the scope of this video. So basically what you would want to do here is you would want to have your players on a note card or a post-it write down their wager based on the category. And I know I do the category and the question at the same time. Honestly, it was over 500 rungs of code when I got to Final Jeopardy. So I was like, here's the category, here's the question. But you would want to have your players write down their wager and write down their final answer before you click to reveal the answer. And then when you click to reveal the answer, Leonardo da Vinci, you would go player by player, check their wager, check their answer, and then tally up their final score. That gives you the winner, the end of the game effectively. If that seems like a little bit of a cop-out to end the game, it is a little bit of a cop-out. This was a really kind of intense project that, again, took me months to build whenever I got a little bit of time. So that's how I finished the game, which is where I'm going to end the showcase per se, and we're going to dive into a little bit of a code walkthrough now, where I will still have the game up just to showcase certain aspects of it, but I'm going to focus on the code that's driving this. So if you decide you want to take the program and make it your own and add features to it and things like that, you have the ability to just by walking through this code together. So the first thing I want to show is how you change currently in the current version of the game that I'm putting up on the GitHub, how you change between levels. So, right, it's only so fun if you only play one level at a time. And I realized when I first was typing up the first level, I was trying to make one from scratch, and I felt like my questions and my answers were all kind of lame. So I was like, dang, I need a way to get a lot of interesting levels fairly quick. So I have a variable in the main game loop, and we'll cover this again in a little bit, but this variable is just correlated to the number of the text file where I store the raw data for the game. And so I'm going to show how I get this raw data from the game, but look, so just by changing that text ID from 8600, which was this text file, to 8601, which was this text file, when I boot up the game now, I get a totally different set of questions. Okay, this is a whole different game now. I have turtles, US geography, all this stuff. If I change that text ID to 8602, I get yet another new game. So that text ID variable is very important because that is where the ID from the text file gets stored. Now, before we dive too much into the main.py file, let's dig into that text ID a little bit more. Why are those numbers what they are, and where do they come from? I built this game initially with the thought that it would take a Python dictionary of questions and answers, and I was just planning on typing up the games and saving some dictionaries and giving you guys a few to reference. And then I realized all of my levels compared to actual Jeopardy levels were super boring and uninspiring and didn't play very well. So I kind of did a side project to build a level scraper that would pop into the Jeopardy archives, which is just a public use website that stores past Jeopardy games. And it would go through and it would check the pages from the past Jeopardy games and store them in a text file so that this game could actually use real Jeopardy levels. So for that, we just need the requests and Beautiful Soup modules to do a little bit of light web scraping. And the whole web scraper function is less than 100 lines, and I don't want to spend forever on it, but basically this URL, I'll actually pull up the Jeopardy archives page real quick. So this jarchive.com website is where fans, I think it is entirely fan run, but they just pop in and they store the answers from past games. So if we were to go to games that I didn't have a text file yet and I click on it and you look at this URL, you can see that between this game and the next game and the next game and the next game, the only thing that's changing is this ID number at the end. And it's not one for one linear, which is, I don't know, a little bit of a different weird thing. But you can see like these three games here, 2682, 2683, and 2684. If you look at the HTML on these pages, if you were to right click and go to inspect on the objects, this is what Beautiful Soup is actually looking at. It's looking at the HTML of a page when you give it a URL. So if you were to copy this URL into your program, which is exactly what I did, but then turn the game ID into a variable, then what you can do is you can pass in an ID number, and you can do this multiple times with one code. You can parse the HTML, and then what I do is I listen for three things. I listen for, let me go up to it, all of the category names, all of the clue texts, and all of the clue responses. I don't even worry about what the dollar amount listed is, because the way the pages are organized is they'll always be coming in the same order. So just by a little bit of trial and error, I realized I could just grab all of the category name, clue text, and correct responses, correlate them appropriately with their dollar amounts, and then save them in text files where the entire thing would just be the gameid.txt. And if I open up one of those, you can see it'll save the category as its own line, and then it'll have Q and then A for the first one, then the second one, third one, fourth one, fifth one. So for single Jeopardy categories, this is 200, 400, 600, 800, and 1,000. For double Jeopardy categories, it's double that. And then it saves Final Jeopardy as well. Still has the category, still has the question, still has the answer. It's just in Final Jeopardy, there's only one thing. So that's a high-level overview of the level scraper. Go ahead and grab it for yourself. Look through it. It's very simple, very straightforward example of grabbing data from the internet. So if you have any questions, let me know about in the comments below, of course. But not going to spend too much time on this one. It pops into the Jeopardy archives, which is just an awesome fan-run website. And then it will export the level to a text format. Now, before we get to the main.py, again, as I alluded to a little bit earlier, I built most of the playable game and then realized I was going to need a level scraper. Sort of realized while I was building this that the easiest way to store this data was in this text file in this specific format. And then I realized that that was not even close to the format that I play the game in. I built the game to play with a Jeopardy, with a Python dictionary. Sorry for stumbling on my words a little bit. So I built another function called getList, which will just read a text ID that we pass it, read the file, and then it will convert that file into the dictionary format that we're expecting. So for example, if I were to run this right now and just do get list and print it, so print get list, and then I'll pass in 4638, Okay, so if I were to run just this little sub function here and print it in the window, what you can see here is it's a dictionary. And I know that formatting's not great and it probably doesn't look good on YouTube. But if I were to copy that and just throw it in this window here, you can see, well, it looks stupid, but dang. But hopefully what you can see is it's converting the, I really didn't think that one through. The formatting looks pretty terrible. I just need to show you guys 2 categories. There we go. All right, so again, if we were looking at this raw text file, it's just a bunch of categories, questions, and answers. But what Jeopardy wants, what the way I built the Jeopardy PyGame file, what it wants is category, title, for the category, and then dollar amount for each question, and then the question, and then the answer in a very specific format. That's my fault for building the game to play in one format and then building a level scraper that stores data in another format. If you store data from the level scraper in this format already, this would be an unnecessary function. I might have done a really bad job of explaining that. I know I did a pretty bad job of explaining that, but the whole reason we have the get list function is so that when you set your text ID here, your questions list can be generated by the questions list.getList function, which is what we just looked at. Now let's look at the actual main.py code. If this goes as smoothly as explaining the level scraper in the questions list, everyone should be confused by the time I'm done. Okay, so really the only modules you need for this whole thing are PyGame and then our questions list .py file. And then you just initialize PyGame. And then really, if you've seen any of my PyGame tutorials or developed in PyGame at all, you're very familiar with most of these boilerplate variables, setting the size and the screen and the font. But even if you're not, I put comments on every one of my variables, so that should help answer. I do have the initial, like the default player and scores here in another list. But you can change these to whatever defaults you want because you can also change them from inside the app when you're actually playing. Now, again, I have 50 rows of just initializing variables, so I'm not going to spend too long on there. Read the comments. Let me know if you have any questions. And let's take a look at 2 things that I made for generalizing some of the code. I built a class for this for button that handles basically every rectangular object with text in it. I keep running questions list. So every single one of these squares that has a question in it, so these dollar signs, as well as the titles, as well as the player names and the menu, these are all buttons. And I built some moderately flexible code so that you could give it different font sizes. You could give it different parameters, like you could actually determine whether or not they were clickable. The overall size of the button, the color of the button, the font size of the text, all of that, all built into this button class. That was huge in cutting down the total number of distinct code. And there's a few fun things here, like checking the position of the mouse and whether or not it's clicking, checking if the button has already been clicked before, if it's able to be clicked, if we need to split the text, or if we can leave all the text in one string. So the button class is pretty cool. The entry box class, I sort of piggybacked off of the button class, but it's a little bit more niche. It's really just used in the edit player information. I wanted to build something that, like, if you were typing, it would feel like pretty much normal typing, where if you had to edit the score, you'd have to be able to click back, you'd have to be able to add, subtract. Down here, you only want to be able to type in numbers, but here you could type in basically any valid character. So these are entry boxes, and they actually, you can see, immediately save when you edit stuff in that menu. So that was the purpose of the entry box class. There's really nothing crazy in here, just calling some variables, drawing it on the screen, and giving it a few special rules in how to interact when characters are being typed. Okay, so those are the classes. Now I'm going to kind of jump over these sub functions that make the game go so that I can enter the main game loop, because the main game loop calls all those sub functions, and it'll flow a little bit better if we talk about it that way. I initialize my entry boxes here just before the main game loop because those are the only 6 entry boxes I ever need, so I can just call them once in the beginning with their default values and then just edit them as the code goes on. So in PyGame, I pretty much always call this the main game loop because it's an endless while loop. Like effectively, if you don't click the X in the top of the button or force close PyGame, you have a while run, and run just equals true. So in programming, an endless while loop is a no-no, which is why like the first thing you should do is come down and put these lines of code in, which is just for event in pygame.event. If event.type equals quit, then run equals false. So that's our escape hatch from this while loop. But I fill it with a dark gray background. That part doesn't really matter because the entire screen has objects drawn on it. And then timer.tick at frame rate, that's just how you control the speed that it plays at. So it's more or less the same experience regardless of the performance of the computer that you're playing on. If it looks a little bit like spaghetti code, it is a little bit like spaghetti code. But essentially, if a menu is not active, that just tells us that you're in the main game environment, the main playing screen. So we want to draw the board and draw the players. And now we'll jump back up and we'll take a look at draw board and draw players. Okay, so draw board. If mode is less than 2, so I use some code to handle drawing all of the buttons for the questions by iterating through the array with 2 nested for loops. And this just goes through and it draws all 30 questions, their scores. If they haven't been clicked yet, it'll draw the dollar amount. If you have already answered that question, it'll just be a solid blue box. And that's the same for single Jeopardy and double Jeopardy. It just checks mode to know whether it should be taking from the first category or the second category. And it just used mode to know if the dollar amount should be 200, 400, 600, or 400, 800, 1200. So that's what mode is doing. But then else tells us that we're in final Jeopardy. And that's just, like I said when I was doing the showcase, that's just showing the category and the answer, and then it will draw a rectangle over the answer to hide it until you click on the rectangle. So that's really all draw board is doing, is drawing the 30 questions and their categories, and then the final Jeopardy stuff. So again, there's a lot of PyGame syntax in here. So I think for a lot of folks who are good with Python but haven't used the PyGame module before, some of it's just going to be getting familiar with the syntax. But it's not a crazy function. And then draw players is really not a crazy function. It is just drawing the names and the scores of each player. So it really couldn't be much easier than drawing some names and scores. And then let's pop down into our main game loop. Okay, so that's if the menu isn't active. And then if the menu isn't active, another thing we're doing is we're checking if the mouse button is being clicked. And again, there's a little bit of separate handling if we are in Final Jeopardy or the main game. But if you've clicked somewhere on the screen and we weren't actively answering a question, then we check where the mouse was clicked and we sort of reset everything and we start answering a question. But if player active is, but if we click and it is Final Jeopardy, we only check one specific zone to know if we want to reveal the final answer. So there's a lot of code going on in the if clicked and mode is less than 2. There's if not active question, where we check to see if we just clicked on an active question. But then there's also if player active is equal to 0. Similarly, we're checking where the button was clicked, and if someone had already gone and you clicked on them again, it won't let them answer again. So a lot of the logic you have in here is like, I thought I had it solved with 2 rungs of code, did a little play test and realized there was an edge case I hadn't thought of. So hopefully most of this makes sense when you're playing around with it. If not, go ahead and ask questions. I'm not going to go line by line since this thing's over 500 lines. But then if we do have an active question, that means we're actively playing. Then one thing I really like is I draw the question, but I get it to grow on the screen. That's one dynamic that I'm actually kind of proud of. It seemed like a waste of time while I was building it. And then when it started working, it was super fun. This, you can click anywhere on the screen and the rectangle will start out as the size of the question and then it'll grow to fill the screen. It's actually really similar to how Jeopardy is played. And that's what the draw question and the grow subfunctions do. So coming back up, if I was drawing the question, then I have these little size parameters that are telling me where to start and where to grow. And then once it gets to the spot where it fills the whole screen, then it draws the text on the screen. So it's a fun little side dynamic that just makes it feel a little bit more like legit Jeopardy. All right, and I'm going to minimize the stuff under if not menu active now because we have else if menu active, and that's where most of the rest of the dynamics come in. So really going back to the game, most of the game is clicking on buttons, a question pops up, you can click on a player, and then you have the yes or no questions come on screen, and the game master just clicks whether they're right or wrong. Basically, all the other dynamics are just tied up in clicking the menu, which sets menu active, and then you have all these different pop-ups that you can go to. And I don't mean it as a cop-out, but load saved level, I actually just felt like it was so easy to change the text ID variable, and it's already a game where you sort of have to know how Python works to use it. So instead of loading a saved level, I just have changing the text ID manually, but edit player information, as I've shown, does work. Create a level, very similar to load a level. Instead of building this into PyGame, I just figured you can take one of these text files and you can just replace the categories and the questions yourself and then use this same format. So it's a little bit more manual, but you're talking about saving hundreds of lines of code by just asking people to do things sort of manually. Rules and instructions, it's not the best formatting, but I did put some legit rules in how to use the program just in case it gets passed around and people who don't know what they're doing use it. Restart current game that one actually works. It'll just take whatever game you're actively playing and it'll reset everybody's scores and all the questions and everything else like that. And then the last menu button is exit the program. Okay, so that's what the menu buttons do, and that's what the vast majority of the remaining sub functions that we haven't talked about yet do. So there's draw menu, adjust the coordinates. Oh, this is related to draw question. This is the one that actually handles ballooning in and out until it fills the screen. Draw yes or no. This is the little sub function that when you click on a player and they're actively answering, this function just draws the yes or no buttons and returns the buttons. Draw rules is the rules menu. Info is the player info menu. Load is the load screen. That's the one that just says would be cool if you added it for yourself. I'm not proud of that, but it is what it is. Build menu, almost identical to load menu. And then check the mode is an interesting one. This is a function that is checking if all of the questions in the current single or double Jeopardy that you're playing are now answered. So if they are, that's when we shift to the next mode. It made the most sense to me to not embed this in the main game loop and build it its own function that checks once after every question gets answered if that was the last question in a level. So that's all the sub functions covered. If you haven't seen event handling in PyGame before, it's just basically for event in pygame.event.get. This reaches into the computer and it gets all the mouse clicks that are going on, all the keyboard strokes that are going on, all the buttons being clicked. And so the first thing it checks is if event.type is pygame.quit, which, as I talked about a little bit before, that is just the X in the top right of the PyGame window, and that will let you close the game, since obviously you set up like an infinite while loop to start the game. And then basically everything else is just directly tied to the events that we're looking at up here, which is if there is no player active and the menu is not active, then that means we're playing the game. But until a person is selected, then clicking the button shouldn't do anything. The yes or no aren't going to show up and anything else like that. But if player active is not equal to 0, that means player 1, 2, or 3 is going. And then you have the chance to click the right or the wrong button. That'll change their score, blah, 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 blah. Otherwise, you have the chance to click the menu button or leave the menu. And then if you click the menu button, then you can set menu active true. But then if you leave the menu, you set menu active back to false. So again, I don't think I need to baby you guys through the event handling, but I'm sure there are specifics you might be wondering if you grab this 542 lines of code, not counting the level scraper, not counting the questions list. I'm sure you'll have questions. I didn't mean for this necessarily to be a code tutorial, more of just a familiarize yourself with what each thing is doing, ask any questions that you may have. I'll probably drop 1 to 5 of these text files in the GitHub with the level scraper and the questions list in the main.py file so that you guys have a few to reference them. But yeah, this is a slightly different type of video for me because I'm used to just sitting down and doing these projects line by line in the tutorials, but those take hours and hours to edit and record and upload, and I'm in a little bit of a phase of life where I don't have the same number of hours I did when I started learning Python and PyGame. So I hope you found this enjoyable, definitely a little bit different, but I have been working on this project for so long that I just really wanted to get on YouTube. I wanted to get on GitHub, give it in the hands of people who might have time to fully finish it off and give it the love that it deserved. So any questions, let me know about in the comments below. Any suggestions for what you'd like to see more of or see next on the channel, let me know in the comments below. If you love the channel, you want to become a super supporter, help me grow it to the next tier, check out my Patreon down there as well. I appreciate all of the support on Lemaster Tech. Thank you so much for watching, and good luck with your projects. We'll see you next time. Thanks. Bye.